We're Team ClassAct, and these past 2 terms we've been developing essentially a rubber mat punch. Our mission statement is to create a device that will increase productivity and ameliorate the working conditions for women in the rubber mat punching industry in Kerala. So, the rubber mats that you see at the bottom of that slide there are really, really common in India. They're used for doormats, kitchen mats, in factories, pretty much everywhere we went while we were in India, we saw them. Currently, the holes in the rubber mats are punched out one by one by women in these workshops, simply with a hammer and chisel, and they just sit there and punch these out. A small mat, which I think is roughly about 40 by 60 centimeters, takes about 3 minutes. However, because they are doing this manually, it causes a lot of pain in their neck, in their backs, in their hands, just the constant stress from punching out holes. So our goal was to improve, number one, the productivity. We wanted to punch out multiple holes at once and be more accurate than the current method, and also finish mats at a generally faster rate. And secondly, we did want to improve the working conditions and try to find a position that the workers would be willing to adapt to, and find something that would use less force or need less force applied by the workers to punch out these mats. So it's an interesting business structure. The mat shops don't actually produce the mats. They get mats from suppliers who ship them to the store you can see in these carts. And after the mats are punched, they sell them back to the suppliers for a margin. So we were working mainly with the shop owners who were getting the supplies and having workers punch out the mats. So we have a little demo.
So yeah, here's a little video of the women workers actually pushing out. It's a little dark, but you can't see it, but you can hear it.
Yeah.
You can hear it. So if you can see, it's about pretty much 1 hole per second. That's not the best light, but that's what we're trying to be.
They never hit their wrists. They never.
They do. That's an issue. That was one of the things we were trying to solve, was that that they get injured.
So they wear no protection on their wrists.
No, sometimes they wear like small gloves, but it doesn't provide as much protection as they like. They still get injured. That was one of the big aims that we wanted to solve.
Yeah.
Go ahead, Shihab.
Yeah. Next is about the initial market study. Firstly, we were able to find that there were about 250 to 300 rubber mat punching shops which use conventional method of punching using chisel and hammer. And we were able to interview a couple of owners and about 30 workers, and we took product specification and requirement from them, and finally we were able to finalize our product design as the spiral notebook type punch, and which could punch mat at a faster rate with minimum effort.
So this is the overall design concept. You guys kind of seen this before, but we wanted to keep we're going to imitate the chisel impact, which is what the staple gun is for. Staple guns have high impact, and increased precision, which is traditional of or characteristic of the hole punch itself. And the hole punch also would minimize and distribute the force from a singular kind of point to across like a handle. So these are the initial designs. Here we have, we showed these to the workers at the shop along with the shop manager. So the ones on the bottom 2 are meant to be operated by hand. You kind of push down and it punches them out. And the one on top is like a slide that you push down and you pull the mat through, essentially. So after showing these to the workers in the shop, they decided on the design you saw at the top. And so here is our first iteration of the design. As you can see, we're using springs to store energy and then release that energy to actually punch out the mats. So first, we have this little catch and release system to do this. So first you pull on backwards on the lever arm after attaching it to the pin of the plate. And then you push down, so that's step 3. You push down to lift the plate up, so that's where all the energy is being transferred. And then you push forward to release the the plate, there's a slot in the lever arm at the very end that allows the plate to just drop freely. So through building this first prototype earlier this term, and through talking even with you guys here, we came up with several revisions. Firstly was to increase the base length. That adds a lot more stability, something that we didn't really account for before. Secondly was to increase the lever arm length, so the handle is further away from the actual chisels and closer to the user. And that ends up decreasing the amount of force required. Thirdly, we finalized the chisel attachments. We were kind of iffy as to how we were going to attach those to the plate itself, but we were able to just use a bolt because we could thread the chisel. Fourth was the spring sizing, perhaps one of the most frustrating issues for us. We didn't quite know exactly how to size these springs, whether it would punch out all of the holes that we needed, because we're punching out 10 at a time instead of just one. Really, actually, we're punching 20 at a time because we are using punching out both the big and small holes per row. And then fourthly was the handle operation. That's actually kind of a little getting ahead of ourselves, but if you see at the top where the plate goes up, so Shihab, go ahead and lift the plate, or lift the app, and then you can see at the top there are these two kind of square things that come out from the side. So if Shihab were to push the handle forward, the plate would drop, but then the force that he has to hold the plate there would also push the handlebar down if those two stops weren't there. So that wasn't there before, but through building the prototype, we were able to see that that was an issue, and subsequently added that, thanks to Sandra, actually. So now this is our current design, just another SolidWorks model showing our design. And this is a picture, a lot of pictures we had of our awesome model, Shihab, there, with the prototype. And so that's our design. And the cost for this prototype is around roughly 2,730 rupees, which is about $50. So fairly reasonable for a prototype cost. We actually didn't have to pay for the materials. We actually priced that using online prices, because we could just go down and there was some scrap in the metal shop that we were able to use. We had to pay for the springs. Each spring was about $3 each for the size that ended up being the ones that we could actually bend or compress.
All right, so we actually managed to get some testing in this morning, finally. That was great. And the good thing was we hadn't really tested the product before today, but it worked perfectly when it was there. So he was really happy with it. The manager. There's just more pictures of them using it, and it worked like a charm.
Oh man! Go back to the one before. That was punched by this?
Yeah.
Wow.
So actually, Shihab was saying when we talked earlier that the spring sizes were actually too much.
Yeah.
It was a lot more force than.
That's how it was some time ago. So you lowered it, but you could lower it even more.
Yeah. So we could.
Which probably make it a little cheaper too. The spring.
Yeah. Also, a new development earlier today, Shihab was able to also. Shihab, you want to tell them about the spring you found?
Yeah, we found a new spring which is a valve spring. It's used in automobiles. It has less stiffness than the previous one.
Okay.
So it's a less stiffness, and because it's found in automobile, I think that they use it on the piston heads in an engine. You can just find actually a scrap parts, because the springs actually retain their stiffness fairly well. So you can actually kind of salvage those parts and still have a useful product.
So we just we created a questionnaire a couple of weeks ago, and they actually went and got the results today. And so we kind of, I mean, these are all obviously very variable, right? If you ask them this questionnaire again the next time, they'll probably have a different answer. But it gives you a gauge as to what they feel. So in terms of comfort level, it seems to be much higher with the machine, which would make sense because it's in the awkward position with the hammer and chisel. While here, you just kind of have to press down. You can stand, you can sit, whatever you like. And the lower back one, they say that it's much easier in the back because again, you're not in an awkward position. So I guess for question 1, question 2 are kind of linked. Now the good one, which we're very happy about, is the chance of injury to the hand is pretty much non-existent now. I mean, obviously non-existent, you can somehow still hit yourself, but it's very significantly reduced from before because there's no hammer and chisel anymore, right? And so
it's got to be easier.
And so it's much easier. I think that the one thing we'll talk about later is that the only time where you could get hurt is when you're trying to increment the mat. But I think what we would like to move forward after this is to actually create some sort of system which automatically increments the mat, the holes. So you don't actually have to do anything except go up and down. So yeah. And in terms of efficiency, I think right now we're not too much quicker than than without the machine. So that's okay. We're still slightly quicker, and I think once we get this little system in where we can increment the mat automatically, we'll be at least 50% quicker than what we are right now. So that'll be great. And failure rate obviously is a big change because now the chisel is perfectly aligned. So there's no way you can have an error. It won't work. Yeah. So So it seems. So that seems like good.
How many mats did you actually make with the chisel?
Shihab, you guys want to?
One mat is punched in about 3 to 4 minutes.
No, but how many mats did you actually make?
We punched only one
Only
mat.
one. Okay.
We're willing to,
No, I'm not complaining. No, it's fantastic. Don't get me wrong. This is 1 out of 1.
Congratulations, 1 out of 1.
No, but the thing is that by concept you can see that there's nothing that's not going to mess up because there's nothing to mess up. It just works. So.
In this picture here, you guys can't actually see, but Shihab said they actually bolted this to the table itself.
Yes, I was going to just ask that. It looks like you got to bolt it down.
So that's why it's on the table and just for more stability because of all the moving parts.
So, yeah, then we want to talk to the manager and see. I mean, the big question of the manager is when you purchase it, right? And so for him, he said he was very happy to purchase the thing if we could do the necessary changes. The major one being the auto increment of the mat. And the great news for us is they said there would be no need to replace any workers because the demand for mats is enough that the more mats you punch, the more money they make. So I guess that concern kind of went away because that was something we were kind of dealing with the entire time.
I remember.
So that I guess pretty good. So a lot of good news today. So that's good. Yeah, this is just quality feedback that Shihab got when he and Jeffin got when they went to the shop. They were all very happy. It seemed very intuitive to use, which makes sense because you're literally just going up and down. Yeah, the feedback is still dynamic. I think we still need to do much more iterations, and this automatic incrementation is not going to be trivial by any stretch of imagination. So that will cause some time and much more testing to be done. So we'll see how that goes. But we're happy.
And next we go on to the manufacturing and the distribution. We have identified Mr. Joshi of Twin Metals as a partner for the manufacturing of the product, and we also have assistance from Mr. Suresh with the spares and parts and also for repair works if necessary. And for distribution, initially we have asked Mr. Shibu of Akil Rubber Mats to help us with identifying different prospective buyers so that we can have a distribution network set up. So maybe and possibly in a later period we can have tie-ups with NGOs, and perhaps a better tie-up can be made up with rubber board, especially in the entire state of Kerala. And next we go to the major challenges that we faced. One of the major challenges was the logistics. It took a long time for the prototype to reach from US to India, and there was also shipping delays, and it has taken like 10 to 15 days for the prototype to reach India, and we were only able to get it today morning. Oh, wow. So we could go to them and get the feedback. So it was all for a lack of time, and also there was delays in getting materials in India because we did not have much materials available, and especially the springs, which were very difficult to obtain. So that was one of the challenges. And what could have been done differently? A more proactive effort in searching for materials, because with the available materials, if we would have looked further in a prior to a, I mean, if you look at them before itself, you may be able to make better of it. You can use different materials. So I think that should be a point. And I said meeting time established at the start, because most of the web was busy with some of the works, and so a time meeting, I mean a scheduled time should be established so that in future we can have a continuous effort on the things that we do. Thank you.
So, working as a team, so pretty much we had developed a more clear division of labor between the US team and the India team. So they did a lot of sourcing out with the customers and a lot of the kind of footwork or the legwork that was needed while we both collaborated on the design aspect as well. Pretty much what worked and what didn't. So we did have some communication problems at the beginning of the term, but those were fixed. The transfer of responsibility from the U.S. to India took a long time, considering that responsibility traveled with the prototype, and that was delayed and stuck in customs for a while. But it got there, and we got some feedback. So I think we're doing well. And moving forward, we feel like this product has a lot of potential, especially since it's not the framework. The idea is applicable to other products or different things. Really, all you need is impact. For any application that requires impact and precision, this type of framework can be applied. So we can even look at different markets and try and apply the same even design principles there. So product is close to being marketable, and we're pretty much at the same level as a hammer and chisel at the very rough prototype stage. So just iterating on that prototype should see a lot more increase in productivity. The customer feedback, telling us about the incrementing of the mat, and that's something that as Anish said, isn't trivial, but can be done, and hopefully doesn't push the price up too much, which is also a concern that we'll have to look at. And we will have some members. I myself will be continuing this term with this product. And so for just a quick little projection to the future, for the first 2 months, we want to try and do 1 or 2 more iterations, and just really the whole cycle of feedback and iteration. So 1 or 2 more of those, and then finalize a design to send to the manufacturer. And then within 6 months, set up a distribution network, find a manufacturer, maybe about a batch of 50 to take around to shops in the immediate area, and market product to just spread the product and open up the market. Yeah, so that's our presentation.
Thank you.
Yeah, we'd like to thank Ken, Katya, you guys. You guys gave us some valuable feedback. Everyone, Jason, Vinay, and especially the people at the Keel Rubber Mat Punching Shop for bearing with us as we try and.
Congratulations on your serendipity, too.
Yeah. I think just fell into place.
Sometimes good things happen too. Any questions, guys?
How susceptible are the base materials to rusting?
So one of the problems that we've identified that they face currently right now is the chisels. Becoming blunt, but the frame itself is actually fairly susceptible to rusting right now. That's something that we definitely have to look at. Through long testing, we've only had the prototype up and running for a day, and that's something that we just have to keep on looking at.
There's no reason why you just can't put oil on.
Exactly, CLP, just teach them how to do it.
But that's a maintenance issue, which sometimes can be problematic. But
that should be too big of a problem.
Yeah, and I'm actually looking at trying to fix the design of the actually pushing in and out. Because currently they're just kind of just metal rubbing against each other. So there's a lot of friction there.
Can you see the danger here that you keep adding little pieces? And you should put a stake in the ground of when you're going to ship it, and everything has to be done before that. And you freeze whatever it is, ship it, well, go make a whole bunch of them, and
that's essentially what we do.
And then you have all the input you're going to collect from those. You're going to then have, let's say, 6 months later, you'll have a redesign. But if you keep iterating it, you know what the problem's going to be. This is so cool that you were able to get something that worked like that the first time out there. It's just fantastic. All right, well done. Great.